All right, our objective today is to be able to write equations for parallel and perpendicular lines, and to use the slope to determine if lines are perpendicular or parallel. In red, I have highlighted non-vertical lines are parallel if they have the same slope and different y-intercepts. Any two vertical lines are parallel. If we take a look at the examples that I have here, y is equal to 2/3 x plus 1, and y is equal to 2/3 x minus 3. Notice that the slopes are the same. Slope of 2/3 in each situation, which means the line will go up from left to right at a rate of 2/3, up 2/3. Also notice that the y-intercepts are different. So the lines will rise at the same rate, but cross the y-axis at different points. That makes the lines parallel. Same slope, different y-intercepts. All right, so let's take a look at our first example. We have two lines. One line is in slope-intercept form. Y is equal to negative 1/3 x plus 5. The second line is in what we call standard form. 2x plus 6y is going to be equal to 12. Our first step is to write both lines in slope-intercept form. Once the lines are in slope-intercept form, we'll be able to very clearly see what the slope of each line is. Will the slope be the same? And what the y-intercept is. If the slope is the same in each line and the y-intercepts are different, lines will be parallel. All right, so let's take this second equation and rewrite the second equation in slope-intercept form. So I have the equation 2x plus 6y. That's going to be equal to 12. To write it in slope-intercept form, we're going to subtract 2x from both sides of the equation. It's going to leave me with 6y is going to be equal to, and I'm just going to rearrange this, negative 2x plus 12. Then, of course, to solve for y, we're going to divide both sides of the equation by 6. Our 6's are going to cancel. Y is going to be equal to negative 2/3. Oops, little mistake there. Let's erase that. Y is going to be equal to negative 2/6 times x plus 12 divided by 6. That's going to be 2. Okay. When I simplify that slope, we wind up with an equation that says y is equal to negative 1/3 x plus 2. So I have one equation where my slope is negative 1/3. My other equation that I'm comparing to also has a slope of negative 1/3. The y-intercepts are different, positive 5 y-intercept, y-intercept to positive 2. If the slopes are the same, y-intercepts are different. The answer to the original question, determine whether these lines are parallel, the answer would be yes. Same slopes, different y-intercept. All right, let's get to our next example. We want to write an equation for a line that contains the following point. Negative 2, 3, and is parallel to the graph of 5x minus 2y is equal to 8. Now, in order to write an equation for a line in slope-intercept form, we need the slope, we need the y-intercept. So my first step is to take this equation here. Let's undo that. My first step is to take this equation here, rewrite it in slope-intercept form. So we have 5x minus 2y. That's going to be equal to 8. Solve that equation for y by subtracting 5x from both sides of the equation. When we subtract 5x, we're going to be left with negative 2y. It's going to be equal to negative 5x plus 8. I'm going to divide both sides of that equation by negative 2. I know that y is going to be equal to, my slope is negative 5 over negative 2. Negative divided by negative is positive. So my slope is going to be positive 5 over 2 times x. And positive 8 divided by negative 2 is going to make that minus 4. So now I have this equation. Y is equal to 5 over 2x minus 4. I want to write an equation of a line that contains negative 2 comma 3 and is parallel to this line. So my next step, use slope-intercept form to find the y-intercept. So I'm going to replace negative 2 is an x value, positive 3 is a y value. So I'm going to take my equation that I just formed, I'm going to replace my y value with positive 3, replace my x value with negative 2. So let's do that. I'm going to write my equation. Positive 3 for y is going to be equal to 5 over 2 times x. X is going to be negative 2 minus 4. When we solve, plus b, sorry. Erase that. All right, plus b. We're going to solve this equation for b to get the new y-intercept. And the new y-intercept will be the y-intercept for a line that is parallel to this line but contains this point. So I'm going to solve for b. I'm going to be left with 3 is going to be equal to 5 times negative 2 is negative 10 divided by negative 2. It's negative 5 plus b. Add 5 to both sides of the equation. Add 5. I get a y-intercept of positive 8. So my equation then will be y is equal to the same slope, 5 over 2. Equation has to have the same slope. The new y-intercept, positive 8. So this line, y is equal to 5 over 2 times x plus 8, will contain my point, negative 2 comma 3, and will be parallel to my original line of 5x minus 2y is equal to 8. All right, let's move on. We want to write an equation for a line that contains 2 comma negative 6 and is parallel to y is equal to 3x plus 9. Now, a lot of the work has already been done for you because the equation is in slope-intercept form, and I see that my slope is going to be positive 3. So we just need the y-intercept for the new line that's going to be parallel to this line. So I use my y equals mx plus b form. I'm going to replace y with negative 6. I'm going to replace x with positive 2. So I'm going to rewrite this as negative 6 is going to be equal to my slope, which is positive 3, times my x, which is 2, and I'm going to solve that equation for b. I get negative 6 is equal to 6 plus b. Oops, that's a b. When we subtract 6 from both sides of the equation, we wind up with negative 12. It's going to be equal to b. My new equation, y is equal to the same slope of 3x plus or minus 12 in this case. These two lines will be parallel because the slopes are the same. Y-intercepts are going to be different. All right. When we're looking at perpendicular lines, two lines are perpendicular if the product of their slope is negative 1. A vertical line and a horizontal line are also perpendicular. An example, y is equal to negative 1/4 x minus 1 and y is equal to 4x plus 2. Those lines are perpendicular because, and here's the key, the product of two numbers is negative 1 if one number is the negative reciprocal of the other. In order for lines to be perpendicular, their slopes, here's a slope of negative 1 over 4 and a slope of positive 4, their slopes have to be negative reciprocals. If I take negative 1/4 and I multiply by positive 4, I'm going to get a product of negative 1. The slopes are negative reciprocals. So if I continue, our first example, write an equation of a line that contains the point 1 comma 8 and is perpendicular to this line here. All right. Well, once again, if a line is perpendicular, I know that the slope has to be the negative reciprocal. So I have to start by finding the negative reciprocal for 3/4. The negative reciprocal would be negative 4 over 3. That would be your negative reciprocal. Right? How do we find that? I take 3/4 and I flip it over 4/3, and I stick a negative sign in front. If my original slope is positive, my negative reciprocal will be negative. If this original slope was negative, the negative reciprocal would be positive. So now I know that I'm writing a line whose slope is negative 4/3 and must contain this point. My x value is going to be 1, my y value is going to be 8. I'm going to replace y with 8. I'm going to replace x with 1. So I'm going to rewrite this as 8. It's going to be equal to negative 4/3 because I'm using my new slope because I'm looking for a line that's perpendicular. My x value is going to be 1, and that's going to be plus b. I want to solve for the y-intercept. Negative 4/3 times 1 is going to be negative 4/3, so 8 is going to be equal to negative 4/3 plus b. When we add 4/3 to both sides of the equation, we wind up with a y-intercept of 4/3 is the same as 1 1/3, so I'm going to write that as 9 1/3 for my y-intercept. My equation then, in order to write my equation, I put together my negative reciprocal slope, my y-intercept, so I'm going to put this together and this together, use my y equals mx plus b form. My m is going to be negative 4/3 times x plus 9 1/3. Right? That would be my equation. Right? Next example. Are the graphs of y is equal to negative 2 times x minus 1 and 4x plus 2y is equal to 6 parallel? How are we going to answer that? Well, if you remember from the early part of our lesson, the lines are going to be parallel when the slopes are the same, y-intercept is different. So what do you think we have to do? Of course, we have to take this equation here, rewrite it in slope-intercept form so we can see the slope and we can see the equation. So let's do that. 4x plus 2y is going to be equal to 6. I'm going to solve that equation for y. Subtract 4x. Subtract 4x. Wind up with 2y. It's going to be equal to negative 4x plus 6. And when we divide by 2, both sides of the equation, y equals negative 4 divided by 2 is negative 2 times x. 6 divided by 2, that's going to be 3. Do we have the same slope? Yes, we do. Negative 2x. Do we have different y-intercepts? Yes, we do. Negative 1 and positive 3. So the answer would be yes. Those lines are parallel. Right, here are a few problems that I'd like you guys to try on your own. Next example, write an equation for the line that contains negative 2 comma 3 and is parallel to y is equal to 5/2 times x minus 4. Now you could stop the recording at this time if you don't want to see the solution, all right, and then pick the recording back up to see the solution, but so you could stop it right now. All right, now let's find the solution. We want to write an equation that contains this point and is parallel. So what do? Simply replace x with negative 2, replace y with 3. So I'm going to rewrite this as positive 3 is equal to 5/2 times my x value of negative 2 plus b, because we're looking for the new y-intercept. 5 times negative 2 is negative 10. This is going to be negative 5, so we're left with 3 is going to be equal to negative 5 plus b, and we add 5 to both sides of the equation, and add 5. I wind up with 8 for my b. My equation, y equals 5/2 times x plus 8. All right, I'd like for you guys to try this one. Now remember, you're writing an equation here of a line that contains 6 comma 2 and is perpendicular to y is equal to negative 2 times x plus 7. In order to write a line that's perpendicular, we need the negative reciprocal of the slope. My slope here is negative 2, so what's the negative reciprocal of negative 2? Correct, positive 1/2. So we need to use y is equal to mx plus b, but my m is going to be positive 1/2 times x plus b. We're going to replace 6 with x, or x with 6, and replace y with positive 2. 2 is going to be equal to 1/2 times 6 plus b. 2 is going to be equal to 1/2 times 6, which is 3, plus b. To solve for b, we're going to subtract 3 from both sides. B is going to be equal to -1. My equation, y is equal to 1 over 2 times x minus 1. All right. Your homework for tonight is going to be page 253, 1 through 12. Also problem numbers 41, 44, and 45. All right. Good luck.